Finally, our Boolean operators and or not can be used to combine any of these conditions together. Let's look at two examples, a simple one from our weather example and a complex one from our purchasing example. So this is a simplified version of one of our previous examples. So in this example, as before, we have today's weather and this time it's cold, but our conditional, instead of checking only one weather type, checks two. We want to recommend a jacket if today's weather is either cold or windy. So if either of these are true, line 5 will run. Here, it's true that today's weather is cold. It's false that today's weather is windy. But that or only requires one of those two things to be true for the entire statement to be true. It's true that today's weather is either cold or windy because it's cold. As a result, line 5 runs and prints jacket to our output. Now, had we used and instead of or in that example, then this if statement would only be true if today's weather was both cold and windy. Now that just doesn't make sense. Cold and windy are two different strings, and so one string can't equal both cold and windy at the same time. But nonetheless, the computer doesn't care if our code doesn't make sense. And so here, it would create today's weather, it would run that check, it would find that it was false, it would skip line 5, and it would just print done on line 6. But you can imagine that and might be used in more useful circumstances. Let's take a look at one. Down here you can see that we're definitely going to use two different ands. Now this is a pretty complicated bit of code. In fact, this is probably the most complicated chunk of code we've seen so far. We've mentioned in our validating purchase example in the past that we might need to check multiple different conditions. We might need to check, for example, if the balance is sufficient, if the cardholder is actually authentic, if the vendor is trusted. So here's a complex chunk of code that actually tests this. Lines 1 through 12 are just setting up our variables to be used in our actual reasoning. It looks like lines 5 through 8 just set up the general context of the world before the purchase is attempted. The balance, the sales tax, the cardholder name, and the list of trusted vendors all make sense whether or not the person is actually attempting a purchase. Then it also looks like lines 10 through 12 are setting up the context for this particular purchase, the purchase price, the customer name, and the vendor name. So all of this code is just set up to allow our reasoning in lines 14 through 22 to actually be interesting. Then when the code runs line 17, it's going to perform a number of different checks. It's going to check to see if the balance is greater than the purchase price times the sales tax, and the cardholder is the same equals the customer name, and the vendor is in the list of trusted vendors. In other words, the purchase will only be approved if the balance is sufficient, if the cardholder is authentic, and if the vendor is trusted. Notice that I said and between each of those. All three conditions have to be true in order for this entire conditional to be true. Note also that each part individually is a little logical expression. It's either true or false that the balance is enough, it's true or false that the cardholder is the customer, and it's true or false that the vendor is trusted. Each individual logical expression is either true or false, and then it's either true or false that all of them are true. In this case, we see that the vendor is in fact in the list of trusted vendors. Verschali's is one of the vendors in our list of trusted vendors. We see that our cardholder does equal our customer. They're both David Joyner. But we see that our balance is not greater than our purchase price times our sales tax. The numbers here are the same from our example earlier, which means purchase price times sales tax is going to be 20.52. So it's not true that the balance is greater than 20.52 because 20 is not greater than 20.52. Because that part of the statement is false, the entire statement is false. So line 19 is skipped, and line 20 runs automatically because the previous conditional was false. And so our output is purchase not approved. Now notice there's something here we haven't seen before. See this slash right here? That slash is just a way of telling Python, hey, this line of code is too long to put all on one line, so pretend like this next line actually occurs at the end of this current line. So you can think of this slash as kind of a ... or a continued on next page kind of note. It just tells Python to interpret the next line as just being copied and pasted onto the end of the previous line, or copied and pasted onto where that slash appears. So Python basically takes that entire line, the next line, and replaces the slash with that text. Now, generally speaking, instead of actually using that, you're going to want to break complicated lines of code down into multiple simpler lines. But for the purpose of visualizing this, sometimes we'll need to use that. Now, we can actually make this even more complicated if we really want to. Here, our initial setup code is the same, except we've added something new. On line 13, we have a new variable called overdraft protection, and it has the value true. Now, overdraft protection is something that some banks have where if you try to make a purchase and you don't have enough balance, they'll go ahead and allow you to make the purchase and trust that you'll pay them back later. So if overdraft protection is true, it no longer matters if balance is greater than purchase price times sales tax. So as before, our first several lines of code are just going to set up our variable names and give them their initial values. And then line 18 is going to check the same conditional. Except now, this conditional has gotten even more complex. It's starting off actually with a parentheses. And the reason it starts off with a parentheses is we want to check this portion of the conditional separately. Overdraft protection can make up for balance being less than purchase price times sales tax, but it can't make up for the cardholder being untrusted or the vendor being untrusted. So we use these parentheses to set up a logical expression using only this OR, and the results of this expression are then combined with the other two portions of our logical expression. Now that all sounds very complicated, so let's step through it real quick. Python is going to start by trying to evaluate these parentheses. That's just based on its order of operations. Is it true that balance is greater than purchase price times sales tax? No, that's false. Balance is 20, purchase price times sales tax is still 20.52. However, overdraft protection is true, and our operator here is an OR. So this entire parentheses is true if either the balance is sufficient or there's overdraft protection enabled. Overdraft protection is enabled, and as a result, this entire statement is true. Now at this point, we no longer really care where that parentheses result came from. All we care is that it was true. Now does the cardholder name equal the customer name? Yep, it still does. And so this portion of the statement is also true. And our vendor is still in our list of trusted vendors. And so the last portion of our statement is also true. So we have true, and true, and true, which makes this entire logical expression true, which leads to purchase approved in our output. That means that line 20 did run, and because line 21 is the else corresponding to that conditional, line 22 is automatically skipped. Now that was a big, long conditional statement, but if you think about it logically, it makes some sense. Does my purchase go through? Well, yes, it goes through if either I have a sufficient balance or I have overdraft protection, and if I am the customer I say I am, and if I am the cardholder of the card I'm using, and if the vendor I'm shopping at is trusted by my bank. We can kind of see how if any of those three things are false, the purchase won't be approved. So even though the reasoning is quite complicated, it still comes from a situation we might encounter in the real world. Notice also the importance of putting a portion of this logical expression in parentheses. If we had left the parentheses out in this example, the result would have been the same. But if we had instead put that condition last and left the parentheses out, it would have changed the results. Overdraft protection would have overridden any previous condition. Having overdraft protection would have overruled any previous logical expression if we ended with or overdraft protection on the whole.